right, now that we have learned all the different rules for derivatives and you've memorized them and you've practiced them so much, let's figure out how we can use those derivatives to figure out certain characteristics of functions or graphs. So in section 13.1, we're going to talk about increasing and decreasing. How can we tell when a function is going up, increasing, and how can we tell if it's going down, decreasing? Well, we know if we're given a picture of a graph, how to tell if it's increasing or decreasing, right? A function is increasing if the graph goes up from left to right, and decreasing if the graph goes down from left to right. We always read a graph from left to right, just like if you were to read a book, we're reading it from left to right, so horizontally. So always talking about x values when we're talking about increasing and decreasing. And if the graph goes up from left to right, up from left to right, up from left to right, we say that that function is increasing in that interval. Or if it goes down from left to right, down from left to right, or down from left to right, we say that that function is decreasing. And that's kind of easy. If they give us a picture, we should be able to look at a picture and figure out where the graph is increasing or decreasing. We're going to go ahead and write our answers in interval notation. So let's look at an example. Example number 1 gives us a function, and it asks us where is this function increasing, where is it decreasing, and where is it constant, meaning it's not going up or down. It's staying the same for a second. If you look at the function, again, from left to right, always x's. We're never reading the graph up and down when we're talking about increasing and decreasing. When we read a graph, we read it just like we do a book. So if I'm looking at this graph and I start way over here to the left, to me, as soon as I hit this path, I'm going to be increasing until I get to this point here, right? -4. And then it looks like I'm going down. I'm decreasing until I get to about 0. Then I'm going flat for a little while till I get to about 4. And then I'm increasing again till I get to x equals 6. And then I'm decreasing, it looks like, for the rest of the time. So if I were to write my answers in interval notation for where I was increasing from -infinity until I hit -4. Then I was increasing again on the interval from not -4, but from 4 to 6. Those are the only two intervals in my graph that I was going up or increasing. So then where would I be decreasing? Well, it looks like on my graph, in interval notation again, I'm decreasing from -4 to 0, and then again from 6 to infinity. And we're saying infinity because those arrows are going to tell us that we're going to continue going down, right? We're using parentheses, if you notice, on all of those different ends, because at the top, let's say, I'm going to use a different color here. Let's say at this point right here, at x equals -4, it's neither going up nor down. That's a point where it kind of changes, right? So I can't necessarily say that it's going up at that point and include -4. So that's why I use the parentheses. Now on this graph, isn't there a place where the function is staying constant for a second, is horizontal? Remember, that was the interval from 0 to 4. So if I give you a picture of a graph, you should be able to tell me in interval notation on what intervals is the graph increasing or decreasing, going up and down. Now, what happens if I take away your picture and still ask you, if I only give you an equation, a function, and I ask you if the graph is increasing or decreasing, or where it's increasing and decreasing, and you cannot look at the graph? Well, let's think about what we know about the relationship of the slope of a graph, remember derivative, and what's happening in our graph. Think about that. How can we use our derivative to figure out if a function is increasing or decreasing? Well, if the slope of the graph, if my derivative is positive, well, if my graph has a slope that's positive, doesn't that mean that it has to be going up? It has to be increasing? And if the slope of my graph is negative, well, then it has to be decreasing, right? So I can say that if the derivative is positive, my graph is increasing, and if the derivative is negative, then my graph is decreasing. So I can tell by just looking at the value of my derivative, if it's positive or negative, if my graph's going to be increasing or decreasing. Now, if my slope of my graph, if my derivative is 0, well, then I know that my graph is constant. And it could be constant in an interval, or it might be just constant at a certain split moment. So if you look at the graphs here, we know that the derivative is, Sorry, I don't know what happened. My derivative is positive. It stops for a second. It's negative. It stops for a second. It's positive. It stops for a second. And then my derivative is negative. My graph was increasing, decreasing, increasing, and decreasing. I can tell by just looking at my derivative if my function is going to go up or down, increasing or decreasing. Let's talk a little bit more in the next example about how we're going to tell that our function is increasing or decreasing by just using the derivative.